Video you can go through that. Right. Now f of x is equal to cos x by 2x by pi, I think 2x by pi plus 1 by 2. What is the condition they given? Where x is not an integral multiple of pi. So when x is a multiple of pi, what will happen? So this greatest integer means this 2x by pi becomes integral part. Okay, so we'll get integer. So here, so that clearly they mention x is not integral multiple of pi, then this will denote the greatest integer function. Then whether this function is odd or even or both even and odd, neither even nor odd. Simple. Again, replace x by minus x, cos of minus x by, see here, greatest integer of, replace x by minus x means minus 2x by pi plus 1 by 2. Since we know that cos of minus theta is, what is cos of minus theta?
Cos theta.
Cos theta. So cos x numerator, and clearly they mention x is not a integer value which is multiple of pi. It is not integer. So x is a rational. Let us consider it is rational. See here, for example, let us consider that this is in the form of like minus 1 by 2 is there. Integral part of minus 1 by 2. So how can you write this integral part of minus 1 by 2? Negative value, it is inside is negative symbol is there, negative minus 2x by pi. So I just am asking what is the value of greatest integer of minus 1 by 2? First it is minus 1 by 2, just simply minus 1. That's it. For example, minus 10.5 is there. 10.5 is there. What about the answer? You have to write minus 10.5 as it is, but minus 1. Because whenever you are having negative, you should subtract with minus 1. Whatever the value, like it is other than integers. If it is an integer, minus 20 is there. Minus 20 direct integer, this is equal to minus 20. But minus 20.1, minus 20.2, so you can add minus 1. So in the same way, what is the value we are going to get? Minus 2x by pi means greatest integer of this minus is okay. Then here minus 1. Okay. Sorry, here greatest.
Can you explain once again, sir, how that's minus 1 came?
Yeah. Minus 1. So here, look at here. If you take the graphical representation, okay, when I take here, like here, minus 1 is there. If I take, I need to find the, this is what, minus 0.5. I need to find the greatest integer of minus 0.5. Negative is there, minus 0.5. Anyone? What does it mean by greatest integer? This greatest integer is equal to, yeah, greatest integer. Here always we are going to get the integer part of this. Like what is the left side value? What is the left side value? Minus 1. So what is the value we are going to get?
Minus 1.
Minus 1. Okay, minus 1, right? So if I want to change it to this plus, like I want to take this minus outside, I want to write in terms of 0.5. So shall I do, what is the greatest integer of 0.5? Anyone?
0.
Shall I write here minus 1, like greatest integer of 0.5? And if we take 0.5, okay, I want to take other than that. You can give any negative value. I'm going to prove that negative of some value. minus any number.
3.5.
Okay, 3.5. Actually, what is this 3.5 value? We are going to get minus 4. Immediately, what is the left side integer of minus 3.5? Minus 4.
Minus 5. 4.
Minus 4. Am I right? Minus 4. So that this answer actually minus 4. Minus 4, can I write minus 1, minus 3? Shall I write minus 1, minus 3? Shall I write greatest integer of 3.5? See
Yes,
what we
sir.
got, minus
Okay,
of
sir.
3.5 is equal to minus 1 minus greatest integer of 3.5. I can, in the same way here, if I want to take minus outside, minus 1 minus of this value, plus 1 by 2. Okay. Simply remember that when n is belongs to r minus, okay, r minus and n is not an integer, then minus n can be written as minus 1 minus of greatest integer. So
Okay,
with
sir.
the help
Understood.
of this, what about here value? Cos x numerator is positive. Then what about denominator? Minus 1. Shall I write like this? Minus 2 x by pi minus 1 by 2. Minus 1 plus 1 by 2. Minus 1 by 2. Is it right?
Yes,
Now,
sir.
now see here. This can be written as minus of. Take minus outside. Minus take common in denominator. This can be written as minus of cos x by, again, 2x by pi plus 1 by 2. Nothing but what about this? Is it even function or odd function? Minus outside.
Odd.
So when we replace x by minus x, we are going to get minus of the same given function. So odd function. Okay, it's a simple question. Not at all difficult, right? F of x by f of x cos x by this value is odd function. First option is correct. Now, periodic functions, if you have idea about sine inverse, especially this value, fractional part of x. This is also can be written as x minus greatest integer. Function is given by fractional part. So what is the period of this fractional part? And what is the period of x minus greatest integer function? Both will be same. Remember that this is always 1. Okay, especially most of them, they are confusing over here. So this curly bracket of x is called fractional part of the given x. That period is 1. Everyone, see here, 0 to 1, between 0.1, every value of 1, it will be getting same value. So for example, 0.1 is there, or 1.1 you can take. What is the fractional part of this 1.1? 0.1. In the same way, 1.1 plus 1, 2.1. So adding 1.1 to, what is the 1.1 plus 1? 2.1. What is the fractional part of 2.1? 0.1. Again, we are getting same. For 1.1, we are getting 0.1 is the fractional part. 2.1 also same. Again, for 2.1, you can add 1, 3.1. So for everyone, we are going to get the same value. What is the fractional part of 3.1? Again, 0.1. Fractional part, nothing but after decimal, whatever the value is there, that is the fractional part. Is it clear? Understood? So the period of fractional part is 1. So in the same way, what is the sign of this x minus, okay, sine inverse x minus sine inverse of fractional part? Also same 1. Cos inverse of this fractional part is also 1. Exponential of fractional part is what? It is also 1. A power fractional part is what? It is also 1. When fractional part periodicity is 1, Then sine inverse of fractional part is 1, exponential of fractional part is 1. That, okay, everything will be same. Clear, student? Okay. And also we studied very clearly. Cos x's period is what? Cos x period is 2 pi. Cos nx 2 pi by n. We clearly discussed about all this in class 11. Okay. So in the same way, what is tan? Tan x pi alone. Tan nx pi by n. And also remember, student, fractional part, just now I tell fractional part periodicity 1. The same fractional part of nx periodicity 1 by n. This difference you need to observe that. For example, fractional part of n into nx plus greatest integer of nx, nothing but what? Again, fractional part of nx. This is also 1 by. They may give in different ways they may ask question. Yeah.
Sir, when we will get fractional part of n, sir, like 1 by n, 1, in what case we get n as the answer?
Okay, n means x by n. We are going to get n because multiply already 1. When it is n is there, you can take right side, and you can take right side 1 by n. 1 by n, actually fractional part of x is 1. In cross multiply to 1, n by r. Okay. And see here, can anyone tell that what is the periodicity of x square? Cos x is 2 pi. What is cos x square? Cos x cube, cos x power 4. No, we cannot define the periodicity of x square. Okay, like x cube, x power 4. We don't have any periodicity, not defined. But we can define like cos x whole power 1 by 2 is there. Whole power 1 by 3 is there. Whole power 1 by 4 is there. Yeah, it is periodicity always 2 pi. It will be repeat. Okay, cos x means cos x can be written as cos of 2 pi minus x, cos 4 pi minus x, but x square will be there. Sometimes negative values, positive values, when we substitute that, it cannot be defined. Okay, so square root of cos x whole power 1 by 2, 1 by 4, or a cube root, fourth root, you can take anything. So cos x means 2 pi, square root of cos x is 2 pi, cube root of cos x is 2 pi, everything will be 2 pi. Like that you have to answer. Okay, now what about this question number 8? 2 power x by, question is which of the following functions is not periodic? See, cos x square is not periodic. So whole sine inverse of cos x square also not periodic. But remaining functions are periodic. Just now I said that this is fractional part. Then the periodicity is 1. Sine inverse of this 1 alone. Even what about this? This can be written as, look at here, 2 power x by 2 power greatest part of x. Shall I take this denominator into numerator? Yes, we can write like this. This is our question. This is equal to, shall I write like this? X minus. This is nothing but what? Fractional part of x again. Exponential. This is a power x form. A power x form. Again, the periodicity is 1. Because fractional part is 1, then 2 power x also 1. Fractional part of x is 1, then sine inverse of that also 1. But see here, cos x is periodicity 2 pi. Root over cos x is 2 pi. Sine inverse also clearly it is a periodic function. Only the thing is fourth one is not periodic function. It is x square will be there, cos of x square. I hope that you understood that. Next, right, see here question number 9, nx plus n, nx plus n. See, this is in the form of x minus greatest integer. Both will be same, nx plus n, nx plus n. Shall I write this value as f of x is equal to greatest integer of x plus nx plus n? Shall I write like this? because x minus greatest integer of x is equal to always fractional part of x. Is that clear, student? In the same way, in place of x, we are having nx plus n, nx plus n. I have written greatest integer of nx plus n. So, can I take n common? Shall I write here n into x plus 1? See, fractional part of whatever you can take, either 2x or 2x becomes, x becomes, here. Remember what I said, what is the fractional part of x? I said period of fractional part. Anyone? Period of fractional part. Twins. 1.
One, sir.
Then x plus 1. X, here you have to observe that x coefficient alone. What is x coefficient? 1. What is x coefficient? 1 only. X plus 1 is also 1. Not only x plus 1, I want to take x plus 100 is also 1 because x coefficient is 1 only. X minus 100. If I want to take x minus 100, then x coefficient again 1. So periodicity is 1. Period is 1. And if I take x coefficient is 2x minus 1, now what is x coefficient? 2. So 1 by 2. This 2 becomes denominator. 1 by 2. 1 by 2. For example, x by 10 is there. X by 10 nothing but you have to 1 is there, you can multiply, cross multiply. 1 into 10 is equal to 10, like that. So here when we observe here, what is the x coefficient here? Student, what is x coefficient? N. What is the fractional part? I mean, of this nx plus n period. Shall I write 1 by n? This x coefficient you have to write the cross multiply 1 already, the period of fractional part. Then x coefficient you can cross multiply 1 by n. 1 by n. Then tan. Yes. F of x is equal to this. If I take n common, then it can be written as nx plus 1. Or even no need to take n common, this can be written as nx plus n plus tan of, what is the value they given? Tan of pi x by 2. This periodicity is 1. This tan period is pi. Now when I cross multiply here, the period is, here it is, n into x, n cross multiply, 1 by n will be. Here, what is the x coefficient? Pi by 2 is there. Cross multiply, pi by 2. Cross multiply means it will become denominator. 1 is there, 1 by n, here pi is there, pi by 2. So which implies 1 by n, comma, pi get cancelled 2. So when we having the sum of two different functions, you have to take LCM. What is LCM of here 1 by n comma 2? Yes, LCM. N is any value. Remember student, here we are going to get integer part. Integer part 2. Here n can take like 1 integers. 1 by 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5. So finally the highest value we are going to get 2. So 2 is the period of the given. Okay, students. So what is the form of actually mathematical representation of periodic function? For example, f of x with a given function whose period is capital T, which implies when we can see the function is periodic function with period t, f of x plus capital T is equal to f of x. So see here, it will satisfy the formula. It is in the form of x plus capital T is equal to f of x. X plus capital T is equal to f of x. What is t value here? 2. Directly they given mathematical representation here. F of x plus 2 is equal to, like, 2 is a period. Directly they given conceptual equation, right? This formula already given. This is the formula for periodic. So directly the answer is 3. And here it is. See, f is periodic. Clearly given function f is periodic. Fine. Then g is a polynomial function. G is a polynomial function. Then f into g of x is periodic. Then and g of 2 is equal to 3 is given. G of 4 is equal to 7 is given. They ask me g of 6. So what they given here? Polynomial. Polynomial means we should consider f of x is equal to ax plus b here. Because for polynomial, linear polynomial having always a periodic. Okay, I can explain you why it is, why we should take f of x is equal to x plus b. So you can take ax plus b, or a polynomial means every quadratic equation is a polynomial, cubic equation polynomial. Okay, we have to take ax plus b because they're given 2 conditions. So we need to find a comma b. Further, they given 2 conditions. Sorry, g of x. G is a polynomial. G of x is equal to x plus b. Now take this g of 2 is equal to 3. Substitute in place of x at 2 here. A into 2. 2a plus b is equal to 3. This is first equation. They give another condition. G of 4 is equal to 7. What is g of 4? In place of x, substitute 4. 4a plus b is equal to 7. All of us solve these 2 equations. This is equation 1. This is equation 2. This is equation 1. Tell me what are the a comma b values? Because they are asking g of 6. G of 6 means 6a plus b. If you solving equation 1 and 2, you are going to get a comma b values. What is a value? What is b value?
Sorry, a equal to 2.
Okay. B is equal to minus 1. Then only now it will be satisfy both equations. Is it minus 1, student?
Yes, sir.
So finally answer is 7.
Sir, 11, no, sir. 16 to 2 plus
Sorry,
9.
sir. 12 minus 1, 11. Is there any option there? Sorry. Okay. Understood? We should take g as a polynomial. G as a polynomial. That polynomial I want to take ax plus b. They given 3 conditions, like again g of 5 is equal to some value they given. When they given 3 conditions, you can take quadratic. Because quadratic having 3 constants, ax square plus bx plus c. 3 constants and 3 conditions. Okay, students. In function concept, the most important concept is that domain and range of the functions and one onto functions. So this periodic concept and all you have to remember, you have to practice. Okay, a domain range, but compared to that periodicity, then one domain and range and types of function, that is one and onto and bisecting. Okay. So we'll wind up the class.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.